You see it in the data before you believe it. December 19th, 2025. An object that shouldn't exist crosses 1.8 astronomical units from Earth. 269 million kilometers. Close enough to measure. Far enough to survive. The third confirmed visitor from beyond the solar system passes through our neighborhood moving at 60 kilometers per second. 57.8 to be exact. Fast enough to escape the sun's gravity forever, this is not a rock caught in our orbit. This is a messenger from another star. Pre-discovery images pushed the timeline back to June 14th. Already moving, already visible, already on a path, no solar system object follows. The orbit shows eccentricity around 6, hyperbolic, unbound. One visit, one chance to see it, then gone forever into the cosmic dark. It, Parker Solar Probe saw it, 10 images per day, 19 days, rolling its axis to catch the view, placing north at the bottom of the frame. Whisper instrument, wide field imager for solar probe, built to watch the corona, adapted to track an interstellar comet passing behind the sun from Parker's perspective. 172 million miles away at the start, 195 million miles at the end. The probe moved away from the sun after its 25th solar flyby on September 15th. Perfect timing, perfect geometry, perfect accident. 25, and peer-reviewed studies in astronomy and astrophysics, including De La Fuente Marcos and colleagues' rotation period analysis from Gran Telescopio Canarias. Observations July 2nd through 5th, 2025. Now back to the information. Exactly when Earth-based observers couldn't track it. Solar glare. Too close to the sun and Earth's sky. Parker filled the gap. The Whisper team had to process out the bright solar corona, adjust for varying exposure times, compensate for stray sunlight. The raw images showed the comet moving left across the frame, background stars streaked, the comet steady, moving, alive. This wasn't just gap-filling data. This was a continuous time series across the most critical phase. When the comet's activity peaked, when sublimation hit maximum, when the nucleus temperature climbed and volatiles erupted and the coma expanded and jets formed, Parker watched it happen in real time, frame by frame, day by day. The images are still being calibrated. Final processing takes months, but the initial data already shows changes. Brightness variations, tail structure shifts, dust emission patterns that don't match standard models. 0.3 magnitude swing in early July, dropped to 0.2 magnitudes later that month. The nucleus getting obscured as activity increased. The coma overwhelming the core. 20 days of continuous observation, shift stack method, deep images. But the signal drowned in noise. 28-hour peaks in the periodogram, same peaks in background pixels, instrumental artifact. No constraint on the rotation period from TESS. The nucleus too small, the coma too bright, the distance too far. Sunward jet, pointing toward the sun. Not away. Radiation pressure should push material outward, but the anti-tail goes the other direction. Projection effect. Dust grains in the orbital plane. Viewing angle creates the illusion. Or something else. The jet wobbled. 7.74 hours? Plus or minus 0.35 hours? Half the rotation period? Single active spot? Lighthouse effect? The jet base offset less than 8 degrees from the rotation pole. As the nucleus spins, the jet precesses, traces a cone, wobbles across the sky. The Parker images span 19 days, 456 hours, 28 complete rotations. If you phase fold that data at 16.16 hours, you can build a composite light curve, track how brightness changes with rotation, map which parts of the nucleus are active, where the jets originate, how the coma responds. Built to image coronal structures, wide field, changing exposure times, stray light from the heat shield, dust streaks from material ablating off the probe, calibration challenges, but the team is working it. Guillermo Stenborg at Johns Hopkins. Applied Physics Lab processed the initial compilations. Philip Hess at Naval Research Laboratory assembled the raw sequences. They know what they have, a dataset no one else can match. A perspective no ground telescope can replicate. 3I Atlas is calmer, more stable, more comet-like. But the periodicity tells you something's rotating, something's changing orientation, and that something is hidden inside a coma 26,400 by 24,700 kilometers across, twice Earth's diameter, all gas and dust. Dust streaming off the nucleus. Background stars streaked because Hubble tracked the comet's motion. The brightest pixel in the image, assumed to overlap the nucleus, contains only a small fraction of total light. Most of it comes from the coma. If you calculate nucleus size, assuming all light is reflected from a solid surface, 10-kilometer radius at visible wavelengths, 23 kilometers at 1 micrometer. Standard albedo 4 to 5%, but Hubble's limit on actual nucleus diameter, 5.6 kilometers upper bound, 440 meters lower bound. The nucleus reflects less than 1% of total light at 1 micrometer, less than 1%. The rest is coma. Harvard astrophysicist, Galileo Project director. The periodicity comes from collimated jets extending far beyond the nucleus, not from ellipsoidal shape. The jets fire, the jets fade, the jets fire again. 16-hour cycle, heartbeat pattern. A puff of gas and dust pumping through the coma every rotation, like blood through veins, like a lighthouse beam, like something you can't ignore. He's been saying it since Discovery Day. Unusual brightness, precise path through the solar system, lack of clear outgassing early on, high stability, high mass. If it changed course near the sun, that could hint at technological propulsion, not gravity, not solar wind, something else. He even joked people should take vacation before October 29th, when the comet reached perihelion, in case it's stranger than expected. Most astronomers dismiss it. Observations from Hubble, SphereX, the ES's Mars orbiters show classic comet behavior. Small, icy nucleus, carbon dioxide-rich coma, water vapor bursts, anti-tail from viewing geometry, natural, predictable, comet. At typical thermal speed of sublimated volatiles, 400 meters per second. Takes a month to traverse that distance. How do jets maintain orientation if 3I Atlas rotates every 16 hours? They should smear. They should spiral. They should show 43 puffs along a 1,000,000-kilometer trail. 23,000 kilometers between each puff. Peas in a pod. But they don't. The jets stay straight. The jets stay narrow. Like they're locked. Like they're aimed. X pattern. Tail and anti-tail along the solar axis. Sideways jets creating the cross. No rotation smearing. No obvious explanation. Unless fragments. Unless breakup. Unless thrust. The closest approach to any planet. The X pattern extending thousands of kilometers at that stage. If breakup started near Mars 2 months before November, ejection speed needs to be 200 meters per second. Delta V from chemical propulsion, very reasonable. Solar tidal force too weak to produce that velocity kick. Natural fragmentation requires something else. Asymmetric outgassing. Nucleus spin-up. Thermal stress or technology. The composition seals it or breaks it. Depends how you read the data. James Webb Space Telescope, August 6th, 2025. An IR-spec instrument, near-infrared spectrograph, asymmetrical coma, gas and dust, water ice, solid H2O, gas phase water, carbon dioxide, carbon monoxide. Infrared spectral features, CO2 to H2O ratio 8:1, highest ever recorded for a comet, 6 standard deviations above typical values. Solar system comets average closer to 1:1, sometimes 2:1, 8:1 is alien, literally. The carbon dioxide dominates, the water is secondary. This comet formed far from its parent star, beyond the CO2 ice line, in conditions where carbon dioxide froze before water, where radiation exposure was different, where chemistry evolved along a different path. The isotope ratios, carbon-12 to carbon-13, similar to Earth. The comet formed in an environment with similar carbon distribution, same stellar nucleosynthesis, same galactic chemical enrichment, but farther out, colder, drier, more carbon dioxide, less water. Lowell Observatory reported it August 22nd. Tentative detection. VLT confirmed it. Nickel and cyanide together. Metallic component, organic component, building blocks from another star system. Time capsule, delivering unaltered primordial material. The chemistry challenges our assumptions. Formation distance, parent star type, protoplanetary disk conditions, volatile distribution. Everything we thought we knew about comet chemistry gets tested by this one object. The nickel atoms escaping, the cyanide molecules forming, the jets pulsing, the 16-hour rotation carrying active regions in and out of sunlight, the wobble in the anti-tail tracing the spin axis alignment. The anti-tail jet wobble during July and August implies jet base offset less than 8 degrees from rotation poles. The rotation axis nearly aligned with the sun direction at large heliocentric distances, over 5 AU, before perihelion. The chance of that alignment occurring randomly, 0.5%, 1 in 200. If the alignment was different, the anti-tail would show much larger wobble. Gaps in activity as the jet base rotates from day side to night side, but no gaps. Steady jet. Aligned axis. Low probability, high significance. To create artificial gravity at 1G, rotation period needs to drop to 1.5 minutes. 3I Atlas spins way too slowly for that. If it's a spacecraft, it's not generating spin gravity. If it's natural, the alignment is just luck. Bad luck for those who want simple answers. Good luck for those collecting data. 7 hours of observation, 102 million miles away. Scanned ultraviolet light emitted by the comet, separated wavelengths, determined composition and distribution of elements in the coma, oxygen, hydrogen, dust signatures, strong outgassing period after perihelion, viewing geometry from sunward position, behind the flow, mapping dust and plasma tail geometry from an angle Earth can't replicate. Combined with Parker's visible light imaging, different wavelengths, different perspectives, different data, same object, same mystery. November 26th through 28th, 17 hours, X-ray emission extending hundreds of thousands of kilometers from the nucleus, solar wind ions interacting with neutral gas in the coma, charge exchange, electrons transferred, photons emitted. The X-ray glow maps the interaction region, shows where solar wind penetrates, where gas density peaks, where the comet bleeds into space. 400,000 kilometers. That's how far the X-ray emission extends. Hubble saw the coma at 26,000 kilometers diameter, the CO2 coma at 348,000 kilometers, the X-ray halo at 400,000 kilometers. Layers, shells, zones of different physics, the nucleus at the center, less than 5.6 kilometers across, maybe as small as 440 meters, surrounded by an active coma, surrounded by an extended atmosphere, surrounded by an X-ray interaction region, all of it moving at 60 kilometers per second relative to the sun, all of it escaping the galaxy's grip. Among 12 he's listed, now 14. The orbit too neat, the path too clean, the geometry too convenient. It passed Mars October 3rd, Venus November 3rd, Earth December 19th, Jupiter on March 16th, 2026. 0.358 AU from Jupiter, 53.6 million kilometers. Close enough for gravity assist if it wanted, but it doesn't. Hyperbolic orbit, not gravitationally bound. One pass, no return. The December 19th approach, 1.8 AU from Earth, magnitude 12.8. Faint, telescope territory, positioned near Leo. Observers with large apertures and dark skies caught it. Smaller optics struggled. The coma spreads out, diffuse, hard to center, hard to track. But observers tried. Thousands of images, hundreds of hours, professional and amateur, coordinated effort. International Asteroid Warning Network running COMET astrometry campaign, November 27th through January 27th, 2026. Using 3i Atlas as test case, refining observing techniques, data submission protocols, centroid measurements on fuzzy objects, future hazard assessment, rapid response astronomy. The comet poses no threat, but the practice matters. Magnitude 13.7 by December 30th. Moving away from Earth and Sun, distance increasing, brightness dropping. By late January, it'll be too faint for most amateur scopes. By spring, observatory only. By summer, gone. Back into interstellar space. 8,000 years to cross the galaxy at its current velocity. Fraction of Voyager's timeline. Natural interstellar courier. Faster than any probe we've built. Carrying information we can't fully decode. Astrophysical journal letters accepted August 2025, reporting the 8-to-1 CO2 to water ratio. Now back to the data. Each one showing the comet against the corona. Each one requiring processing to extract signal from noise. Each one carrying information about tail structure, coma brightness, dust distribution, jet activity during the most critical phase. When the full data set drops, researchers will have continuous coverage across perihelion. They'll phase fold it at 16.16 hours. They'll stack frames at identical rotational phases. They'll build composite images showing how the comet looks at 0 degrees rotation. 90 degrees, 180, 270, full cycle. They'll track jet activation, measure coma expansion rates, correlate brightness with heliocentric distance, test outgassing models, constrain nucleus properties. Every wavelength, every perspective. Building a complete picture of an object that shouldn't exist in our data logs, that came from somewhere else, that's passing through, that we'll never see again. If it's jet activity, single peak, one maximum when the active spot faces optimal angle. If it's complex rotation, non-principal axis spin, the period might not be stable. Variations over time, nutation, precession, tumbling. Parker's long baseline can catch that. 19 days is enough to see period drift, enough to detect instability, enough to distinguish rotation from outgassing. Loeb's analysis points that way. The coma dominance supports it. Less than 1% of light from nucleus, over 99% from jets and coma. The brightness variations track outgassing, not shape. The 16-hour cycle is activity cycle, not rotation period. Unless they're linked, unless rotation controls which ice pockets see sunlight, unless the nucleus is differentiated, patchy, heterogeneous, active regions separated by inactive crust, then rotation and outgassing are the same thing. The spin brings volatiles into sunlight, sublimation begins, jets form, coma brightens. Rotation carries that region into shadow, sublimation stops, jets fade, Coma dims, 16 hours later, repeat. If the spot is offset from the pole, the jet precesses. Traces a cone as the nucleus spins. The wobble period is half rotation because you see the same jet orientation twice per cycle. Once on the way up, once on the way down. The cone angle determines wobble amplitude. 8 degrees from the pole, small cone, small wobble, tight constraint on jet location, near the rotation axis, nearly polar. Nearly aligned with the sun when the comet was far out, before perihelion heated everything up. The Parker images could show that, if they're calibrated precisely enough, if the photometry is clean enough, if the signal isn't buried in systematic noise. Excess velocity not explained by gravity or radiation pressure. Loeb argued for light sail, solar sail pushed by starlight. Artificial, technological. Most astronomers said outgassing, invisible jets. Sublimation we couldn't detect, natural. Both sides have math, both sides have models. Neither side has proof because Oumuamua left before we could study it properly. Spectral lines, C2, NH2, CN, nitrogen rich. Carbon chain depleted. Fragmentation event. Boulder-sized piece broke off March 2020. Natural, active, predictable, most like a solar system comet. Formed around another star but behaves like ours. Composition slightly different. Chemistry revealing formation distance, parent star type, but fundamentally comet. Spectral lines CO2, H2O-CN, nickel, but weird. CO2 dominated, 8-to-1 ratio, highest ever seen, jets that don't smear, rotation axis aligned with the sun, low probability geometry. 14 anomalies according to Loeb. Enough to question, not enough to conclude. Right in the uncomfortable middle where you can't dismiss it and can't confirm it. Where the data is rich but interpretation is contested. Where every new observation adds complexity instead of clarity. When sublimation was strongest, when jets were most active, when the 16-hour cycle was clearest. Each scenario has implications. Each tells you something about nucleus composition, surface properties, volatile distribution, dust-to-gas ratio, thermal inertia, coma opacity. Tidal forces, spin up from outgassing torque, 3I Atlas past 1.4 AU from the sun, not as close as some, closer than others. Enough heat to sublimate volatiles, not enough to shatter rock, unless the rock is weak, unless the nucleus is rubble pile, unless it's already fractured from its long journey. Eccentricity 6, unbound. Follow it back through the solar system, out past Neptune, past the Kuiper belt into the Oort cloud, then interstellar space. But which direction? Which star system? The velocity vector points to a region of the galaxy, but stars move. The comet took millions of years, maybe billions. The star it left behind isn't where it was when the comet launched. Formed early in galactic history, when metallicity was different, when chemistry was different, when planetary systems assembled from primordial material, closer to Big Bang composition than solar composition. The thick disk stars are billions of years old. Their planets formed billions of years ago, comets ejected billions of years ago, drifting, wandering, falling through intergalactic space until a random encounter with the solar system bends the trajectory inward. It happens to pass through our system. It happens to be detectable. It happens to be interesting. But it doesn't care. It's not conscious. It's not steered. It's debris, ejecta, exile, wanderer. Message in a bottle if you want to read it that way. But the message is chemistry, isotopes, composition, formation conditions, not language, not signal, not code. Unless the alignment is deliberate, unless the 16-hour cycle is not rotation but pulse, unless the Parker images, when fully processed, show something that can't be explained naturally, something too regular, too stable, too precise, then we have a problem. Then we have a question we can't answer with chemistry and physics alone. Then we need to consider alternatives, not assume them, not embrace them without evidence, but consider them. Test them, rule them out if possible, confirm them if necessary. The geometric perspective, the most unique. When that data is fully processed and released to the planetary science community, the analysis will begin for real. See which one produces the tightest light curve, the cleanest phase diagram, the most coherent structure. That's the true period. That's the rotational heartbeat. That's the clock ticking inside an object from another star. Project the Future Evolution. Will 3I Atlas survive its passage? Will it break up? Will it fade quietly? Will it brighten unexpectedly like some comets do? Will it do something no one predicts because it's not like any comet we've studied before? The story is still being written. We know more about 3I Atlas than we knew about Oumuamua, more than we knew about Borisov at this stage, but we still don't know enough. We still have questions. We still have anomalies. We still have debates. And that's how science works, not with answers, with better questions, more precise measurements, tighter constraints, narrower uncertainties. The wobble is real, the CO2 dominance is real, the nickel vapor is real, the X-ray halo is real, the hyperbolic orbit is real. 3I Atlas is from somewhere else. It passed through here. We saw it, we measured it, we're still measuring it. And when it's gone, when it fades below detection limits and disappears back into the dark, we'll have the data, the images, the spectra, the light curves, the orbital elements, the chemistry, the physics, the record of a visitor from another star. Each one containing information about an object that traveled further than anything humans have built, that came from a place we can't identify, that's going somewhere we'll never see. They know how to extract signal from the noisiest environment in the solar system. A comet is easy compared to that. A comet is bright. A comet is small. A comet is isolated. They'll get the photometry, they'll measure the tail, they'll track the motion, they'll deliver the data set, and then the planetary science community will do what it does best: argue, test, model, debate, publish, revise, until the picture becomes clear. Until the anomalies get explained or confirmed, until we understand what 3I Atlas is and what it means. They'll reveal structure if the light curve has features, and if the period is wrong, if 16.16 hours doesn't match the Parker photometry, that tells you something too. That tells you the ground-based measurements missed something. That tells you the activity changed between July and November. That tells you the nucleus evolved. That tells you 3I Atlas is dynamic, variable, unpredictable. Either way, the data guides us. Either way, Parker Solar Probe delivered the missing piece, the gap filler that wasn't supposed to be important, the contingency observation that became the centerpiece, the accident that revealed truth. Because that's how discovery works. You can't predict it. You can't force it. You build the instruments, you fly the missions, you point the cameras. And sometimes, rarely but sometimes, you catch something extraordinary, something that shouldn't be there, something that changes how you think, something from somewhere else. Locked in 190 frames, spanning 19 days when Earth's astronomers were blind, but Parker could see. When 3I Atlas was at its brightest, its most active, its closest to the sun, when the 16-hour rotation brought active regions in and out of sunlight, when the jets fired and faded and fired again, when the coma expanded and the tail grew and the X pattern formed and the nucleus survived or fractured or did something we haven't imagined yet. Unaware of the debate it sparked, unaffected by human interpretation, just rock and ice and chemistry and physics following the laws that govern everything everywhere. Maybe the Parker images, when they're finally ready, show something that doesn't fit the models, something that requires new physics or new chemistry or new willingness to consider what we've been avoiding, that we're not alone, that we've been visited, that 3I Atlas is a message, that someone is listening. Chemistry that's different but not impossible. Jets that seem weird but have explanation. Alignment that's improbable but not zero probability. 16-hour period that's rotation-driven outgassing, not technological pulse. Parker's images will confirm that. The phase-folded light curve will make sense, the models will fit, the anomalies will resolve, and 3I Atlas will join Borisov in the catalog of natural interstellar comets. Interesting but not revolutionary. Different but not alien. A visitor that showed us chemistry varies across star systems, but physics stays the same. November 5th, showing 3I Atlas near perihelion in continuous 10-per-day coverage with photometry and tail morphology and coma structure and everything else locked in those 190 frames. When that happens, the phase folding begins. The 16-hour cycle gets tested. The jets get mapped. The rotation gets confirmed or denied. The truth gets one step closer. We monitor the astrometry campaign. We follow the papers as they post to Arxiv. We read Loeb's blog updates. We check NASA's mission pages. We anticipate. We speculate. We argue in conference hallways and Twitter threads and peer review comments. Because that's what 3I Atlas demands. Attention, scrutiny, rigor, skepticism balanced with openness, data-driven conclusion delayed until data is complete, patience, discipline, science. Parker Solar Probe gave us the gift, the observation window no one planned for, the geometric accident that became essential data, the missing link between July ground-based photometry and December close approach imaging. 19 days of continuous coverage during the most dynamic phase. The spacecraft designed to study the sun turned toward a comet and caught perfection, or caught weirdness, or caught both. The final calibrated images will tell the story. The phase-folded light curve at 16.16 hours will separate rotation from outgassing or confirm they're the same thing. The tail structure evolution will show whether the X pattern is projection effect or physical separation. The brightness measurements will constrain nucleus size or prove it's unmeasurable because coma dominates. Every question has an answer waiting in the data. Every mystery has a resolution hidden in the photons collected by WSPR between October 18th and November 5th, 2025. Parker saw it, Parker recorded it, Parker will deliver it. That's when we move from debate to conclusion. That's when the 16-hour period either confirms natural comet rotation or breaks the model entirely. That's when we know. Not guess, not argue, know. Perfect timing. Everything aligned, everything recorded, everything waiting to be unlocked through analysis and modeling and peer review and publication. The science is happening. The truth is approaching. The mystery is solving itself one calibrated photon at a time. The Parker mission continues. The spacecraft is healthy. The instruments are functioning. The data is secure. When it's ready, it publishes. When it publishes, we analyze. When we analyze, we understand. That's the cycle. That's the process. That's how 16-hour rotational periods in interstellar comets become more than speculation. They become measurement. They become fact. They become the foundation for the next question and the next observation and the next discovery that comes from somewhere beyond the solar system and passes through our neighborhood just long enough to be seen. The truth hides in 190 frames, showing a visitor from another star spinning every 16 hours with jets that pulse and wobble, that reveals, and chemistry that challenges and orbit. That proves it came from somewhere else, and it's going back there, and we'll never see it again, but we saw it once, and Parker caught it at perihelion, and that's enough. That's the gift. That's the revelation. That's what the image set reveals about its true nature. Not alien, not artificial, not impossible. Just different, just distant. Just delivered to us by chance and circumstance and gravity. Just a comet, just the third. Just the beginning of understanding that the universe is bigger than our theories and stranger than our models and full of things we haven't seen yet. Until we point the right camera at the right place at the right time and catch 16 hours of rotation that changes everything or confirms everything or does both at once, because that's what good data does. It answers old questions and asks new ones. And 3i Atlas did that better than anything since Oumuamua, and we're still processing what it means. And Parker gave us the tool to figure it out. And when the results publish, you'll know for certain what a perfect 16-hour phase full target looks like when you catch it at perihelion from inside the corona's glare with a spacecraft that was never designed to study comets, but did it anyway, because opportunity knocks and instruments answer, and science captures truth one photon at a time.